Hello, class. We're going to go ahead and get started on Chapter 3. We're going to look at the measures of center today. Before we get started on too much of the different terminology, the most important thing from today's lesson is to make sure you know what variable represents what information as we go through the measures of center, because as we keep moving forward in the class, you're going to want to know those really well. So, for example, all of these pieces of information on this slide about the arithmetic mean or average are important to understand what the variables and symbols represent. X always represents an individual data point. Okay, so if my test grade was a 90%, X equals 90 would be my data point. Lowercase n is the number of data points in a sample. Uppercase n is the number of data points in a population. Now, there's two ways that you can kind of see the difference of sample versus population in terms of the symbols. One is lowercase is always sample, uppercase is always population. The other way that you might see things is you might see something with an English letter in it and then something with a Greek letter. The Greek letter is always the population one. Okay, now what this is saying is this is how to find the mean of a sample, and this is how to find the mean of a population. The sample mean is called X bar. It's X with a line over it. That's called X bar. So if you ever say X bar, that's the sample mean. It is found by sigma X over N. You say, oh man, sigma X, I'm not sure what that is. Some of you will recognize that from sequences and series when you had added up a bunch of numbers. Some of you may recognize that from like an Excel spreadsheet when you have to auto sum or add up a column, for example. This auto sum button is a sigma button. So what this is saying is add up all the numbers and divide by however many there are. That's how you find the average anyway. Add up all the numbers, divide by however many there are, and that will find the sample mean. The population mean is found doing the exact same thing. It looks the exact same. It's just instead of lowercase n, it's uppercase n, and that's just the population number of data points as opposed to sample. It is not X bar, it's denoted mu. It's the Greek letter mu. Kind of looks like a U with a tail on it. It's supposed to be kind of an M looking shape. Okay, so X bar, sample mean, mu, population mean. And you have to understand what those variables are representing as we move forward in the class. It will really help you to be successful. Some good things about the mean is it's very consistent. Okay, if I take the sample mean of a class test average and a sample mean in another class test average, it should be similar. Another plus of the mean is that all the data points are taken into account. Even outliers are taken into account. However, an outlier really does affect the data. Okay, so for example, if everyone gets a round average on a test and then someone really bombs the test or really does well on the test, it's going to throw off the average. And that's where skewness starts to come into play as we're looking at some graphing of histograms. But overall, the mean is still very reliable and very important to use when comparing data and looking at it. The next piece of information is the median. Now, you've probably dealt with the median before. It's the middle number. Now, the important thing about finding the middle number is it has to be in order from least to greatest. Okay, so if the data is not ordered, you're going to have to sort it somehow from least to greatest. Remember, the median is the middle value. It's denoted as x tilde. To be honest, this isn't shown as much. I'll show it a little bit as we go through. The x bar mu idea from the sample mean is much more important than this one, but you may see it from time to time, so I didn't want to forget to give it to you. This goes back probably even to middle school, where you kind of look from the ends and you say these two match, these two match, these two match, and if there's one number in the middle, if there's an odd number of data points, there's going to be one number that will be the sample median. If there's an even amount, you get to the middle and average the two middle numbers. That would be the median for an even set of numbers. So just a few different options here. That's something that you've seen before and can be helpful for those situations. The main benefit of looking at the median in addition to the mean is that outliers don't really affect the median. So if all the data is kind of here and there's one outlier way off to the side one way or the other, that's okay because the middle numbers are still going to be close to one another. And so you can use the mean along with the median to say, oh man, the mean and median are really close. That's probably a good sign. Oh, the mean is way different than the median. There's probably an outlier in that situation. The next one is the mode. The mode is the one that occurs most often. It's a simple one to find. It's possible that a set of data could have more than one mode. If it has two, it's called bimodal, and after there's two of them, it's multimodal. Some students get confused if there's only one of each number. They say, oh, it's multimodal. But if there's only one of each number, then there's no mode. Okay, so if there's only one of every number, there's no mode. There has to be more than one, okay, of something in order for there to be a mode. One that you probably haven't seen very much that could show up from time to time is the mid-range, and this would be the new one. The mid-range, if you think about range, it was highest minus lowest. Okay, highest minus lowest to find the difference between them. Mid-range is a little bit different. It says what's halfway between the highest and lowest. So if my highest value and lowest value are 0 and 100, I would add those two numbers and then basically divide by 2. I average the highest and lowest numbers. It's not used very much unless you want to see the distance and where the middle number would be in between those two to see if it matches up with the mean and median. Outliers affect the mid-range a ton. So they may not be used as often, but I also wanted to make sure to introduce it to you. Okay, when it comes to rounding, I've said this at different times in different classes. Don't round until the very end. Use as many digits on your calculator as you can, and then your final answers will typically always carry one more spot. So if everything's in whole numbers, it'll probably be to the nearest 10th. If something's to the 10th, it'll probably be to the nearest 100th for the answer. It's probably one more spot than what it is. There will be times I just do nearest 100th sometimes just because it's easy. That's 2 decimal places and we move on. But your book also focuses on this one more idea when it comes to rounding. Okay, a review of skewness. We talked about bell-shaped curves and symmetric graphs. This is a normal distribution. This is what we want to occur for a data set. And here's what happens in terms of measures of center. The mean, median, and mode should at least be close, or ideally, if it was perfect, they'd be equal to one another. But if all three of those things are close to one another, it's probably a symmetric graph. So if the mean, the median, and the mode are very close to one another, okay, and that probably means it's a bell-shaped or normal distribution. If, however, the data is skewed one way or the other, this is the same information we saw before. Skewed to the left, remember, is where the tail is. Okay, skewed to the right is where the tail is to the right. Okay, skewed to the right is positively skewed. Skewed to the left is negatively skewed. What this says is where the mode is compared to the mean and median. Now, the mean and median could switch places. Okay, that's not as big of an issue. It's where the mode is. So if the mean and median are lower than the mode, if the mode is higher, it's probably negatively skewed because the ones that occur most often are higher, which moves everything over a little bit, and the mean and median is a little bit lower, which probably means there's some type of outlier to the left side. On the flip side, if the mode is less than the mean and median, like significantly different, then it's probably a right skewed or positively skewed graph. So the mean, median, and mode can also be used to explain skewness, okay, as opposed to just looking at the graph. Okay, this next table here is one that you want to make sure you understand really well. It's one that your programs on your homework can't solve very well, and you're going to have to be able to explain it yourself. It's finding the mean from a frequency distribution. What we're going to do is use class midpoints to find it. And the question is, how do we find the average or the mean? Okay, so in white here is what will be given to you. You'll have to find the gray part. So the first thing to do is to find the class midpoint. I add up 0 and 9999, divide by 2, and I get this number, 4,999.5. Take 10,000, 19,999, add those together, divide by 2. That's how I get this class midpoint. First step, find the class midpoints. Then, to find the class total, you just take the frequency times the midpoint, that's the total. Frequency 90 times the midpoint, find the total. Once you do that, you add them together. Okay, so you take the two class totals, add them together, but then the mistake that students make is they try to divide by 2 because they say, oh, there's 2 groups. It's divide by the frequency, and the frequency in this case is 136. So you're going to have to divide by 136 in order to find that answer. Your number should be in the data set somewhere, so it better be between 0 and about 20,000. If you divide it by 2, you're going to get an answer that's way too big. So you want to make sure you're looking at that and understanding this graph, this table, because this is one you're going to have to do for any testing situation, and you're going to have to be able to solve it kind of on your own. Okay, the last piece is just a data set. Find everything, mean, median, mode, and mid-range of the data. Probably a good setup to start with is ordering the data for the median. You could add them all up to find the mean. Okay, the mode should be easy to find once you order the data. The mid-range is easy to find once you move the data from least to greatest. So you want to order this data from least to greatest, and then once you do that, you need to make sure that you can find the mean, median, mode, and mid-range. So if you pause it here, you can order the data, Okay, if not, you need to make sure you understand all those four things, and here would be the answers. Okay, so you need to double check and make sure you can get those four answers for those pieces. And then there may be a question about skewness. You can make a histogram and look at StatCrunch. You could also look at the mode versus the mean and median. Look at how the mode is much smaller than the mean and median. If the mode is much smaller, remember that if that's the case, that's this situation right here. The mode is smaller than the mean and median, and so that's skewed to the right or positively skewed. There's a lot of information there. Make sure you think about mean, median, and mode, how to find mid-range, and what the variables represent for those situations. Have a good day, everyone.